Assalamualaikum warahmatullahi wabarakatuh, and good afternoon, ladies and gentlemen. Welcome to the workshop of the DigiBiz Talk, Integrating Data Analytics into the Enterprise, brought to you by AITI. This session is a continuation from our seminar this morning, but if you've missed that, keep an eye out on Recap socials for the video. I would like to extend a very warm welcome to our experienced trainer for today, Jackie Tan, who is joining us today all the way from Singapore. He is the head of Tribe Academy, and he'll be here to take everyone on this journey through data analytics using Colab and Tableau. With that, I give the floor to you, Jackie.
So earlier today, we have had the chance to take a look at the power of data analytics, correct? So now it's our turn to do a bit of hands-on data analytics. I will be focusing a lot more on Tableau, Google Colab. Okay, let's see how much time we have left at the end of it, right? So it really depends on the time and pace, right? So once you download and install Tableau, this is what you will see if you open it. But if you have not, don't worry about it. So before we open our Tableau, let's do something else. I am going to introduce to you the data set that we're working today. So what we are doing is that, okay, I think I'm sharing my screen, right? Okay, great. So my screen, what I'm going to show you is a table, okay, from a Singaporean website. So one fun thing about the Singapore government is that we have a very open data policy. What does it mean? It means, right, at any point in time, let's say if you are interested in a particular statistics, you most likely are able to find it within the government's website. So in our case, we are going to use Tableau to analyze the graduates from universities' first degree courses by type, of course, right, and sex annually, right, from the first time the data was collected all the way to 2019. Don't worry about the website. What I'm going to do right now is that in the chat, I'm going to share the file. Just give me a second while I upload the file into the chat, and then you can download from there. All right, fellas. Okay, so in the chat right now, right, you will have seen that I shared a file called practical1data.csv. Please let me know if you can see it. Practical1data.csv. Just give me a thumbs up in the chat if you see the. Yep, okay, great. So click on it, download it, save it somewhere where, yeah, just basically save it somewhere. So that file that we've just downloaded, right, contains, I can click to open, right? So it contains the table that you saw, right? Well, we're not gonna export it directly from the website. We're just gonna download from what I gave you guys, and y'all can check it out. Okay, so this is the year, the sex, the type of course, the number of graduates from each course over time. After you open it, right, fellas, I need all of you to I guess save it somewhere, because we will be opening the file somewhere. So what I need all of you to do is once you click into practical1data.csv, what I'd like you to do is just save as somewhere. I will save it on my desktop. The reason why I want to save it on my desktop is so that it's easy to retrieve later on. So save it on your desktop so you can connect to it easily. Otherwise, it'll be, yeah, it's just hard to find the data later on. So save it on your desktop, okay? Okay, so let's begin. Okay, I hope all of you are excited. Let's open up Tableau. So I have opened up mine. Okay, so open yours up as well. Now, how are we gonna do this? I'm assuming most of you are working off only one screen, so don't worry. So this is how I'm going to teach you guys, because it's a hands-on thing, right? So what I will do is that I will first do something, and then I will show all of you, and then next you will try it on your own. So what happens is that maybe I say, okay, open the file, and based on my instructions, you follow me and open the file. And if you ever find yourself lost, or if you need help, or if you're unable to, I guess if you didn't quite catch my instruction, let me know in the chat and I will repeat what I said. Okay, so don't worry about it. So once again, what I'm gonna do is that I will give you a series of instructions and then I will show you, and then after that I will stop and then you follow me. All good, everyone? Don't worry if you only have one screen. So first things first, right? Let's talk about what you see over here. This is what you see when you open Tableau, right? And here you have connect to a file. So don't do anything yet. This is just me introducing to you all the different parts. Now, the reason why Tableau is so powerful, right, is because you can connect to a server, you can connect to Excel, text file, and a few other kinds of file. But in fact, right, you click over here, right, you click more. Oh wait, cancel, sorry, not more. You to a server, right, you have SQL Server, MySQL, Oracle, Redshift, more. You click on more, right? Wow, that's a lot of different connectors out there that you can connect to. So if your company happens to work off, for example, SAP, right? You can connect to SAP. If you work off SharePoint, I think someone was doing SharePoint, right? Someone was working on SharePoint. You can work off SharePoint. Snowflake and all of these are very, very popular databases. So you have, I think you have PostgreSQL here, MySQL, Hadoop, right? So on and so forth. So I hope all of you might notice or recognize one of more different things over here, right? Yep. So anyways, back to file, right? Back to file. I'm just gonna, what I'm gonna do is I'm gonna click this and close it. Now, first things first, if we want to do data analytics, what do we need? It's not a trick question. What do we need? Data, right? Thank you, Sai. Okay, so let's do this. Let's click on text file. I think it's text file. Yes. Let's click on text file, and we will look for the file that we just downloaded. Practical one data. Okay, so I'm gonna stop here for a while all of you give it a try. So once again, click on text file. So I'm just gonna go back and show you. So click on text file and connect it to your practical one data.csv. Okay, so where was I? There we go. You will see this. Give me an okay in the chat when you see this. Okay, perfect. All right. So Tableau is very powerful. When we load data, right, what happens is that Tableau will try to guess what type of data you're working with over here. What type of data you're working with over here. Now, when you see this over here, right, when you see, you hover over the hashtag sign. So give it a try. Hover over the hashtag sign. You see that there's the button will light up. So what does this mean? Hashtag means number. Okay, so okay, sorry. So you click this, right? When you click on the hashtag, what do you see? It says number whole. Is this correct? No, not really, because what are we looking at? It's actually a year, right? It's a date. So we should be changing the number to date, because right now, right, we're looking at a number. This is not the year. This is not a date. That's not good. But the reason why it guesses as a number is because we only have the year. So it just guesses, oh, okay, it's a number, but that's not it, right? So we click on the hashtag, we change it to date over here. Good, okay. Now this is correct because now it is a date. Make sure that you have 1/1/1995, okay? 1995. Let's take a quick look at number of graduates. So is this correct? Okay, we start with sex. Is sex correct? What is a string? A string is a string of characters. So that's why it's called string. Over here, is this correct? Is this a string? Also, yes, correct. Great. Now, last final one. Is this a string? Is this supposed to be a string? No. So, fellas, what shall we do? We should change this to decimal or whole? Whole number, right? Because there are no decimals in place. So we just click on whole, right? Before we click that, notice something, okay, folks? Okay, there we go. What is there any difference? Is there any interesting difference that you saw? Now, right? Now. The now is very special. The reason for that is because now means empty. And now is quite a special type of data in not just Tableau, but across every other numerical kind of work, right? So this is just indicate that it's empty. Now it's empty. Before that, there was NA. Okay. So I'm just gonna give you guys maybe 1 minute, right? Just 1 minute for all of you to edit this if you have not. So once again, the different thing that we did was that we clicked on this. Initially, it was number. Then we turn it into date. Second thing is that initially it was number. Initially it was string, but we turned it into number, and then we got now. Okay. Any questions so far, folks? Let me know in the chat if you have questions. Okay, good. So let's continue. Now with this, we are now ready to analyze our data. I think you might have noticed there's this thing over here that's highlighted in orange. So if you installed your Tableau recently, you will see something like this. It's just to say that, hey, the data source has been connected. You're now ready to go to your sheet. There we go. Okay. Wow, it's so empty, right? It's so empty. Oh no, what's gonna happen? So before I proceed, right, before we do anything, I'm going to explain to you what are the different things that's going on over here, okay? So I think a lot of people fall in love with Tableau, right? Because it is easy to use. So over here, we have our row, no, not our row. This is our column. This is our row, right? And how it works is that the what we call here are pills, P-I-L-L-S, pills. And the pills, right, you can drag and drop it somewhere, okay? You can drag and drop it somewhere. When you drag, say, for example, let's say you can try later. So if I want to do some kind of analysis or measures on my numbers, what I can do, right, is I can drag number of graduates somewhere, right? You can see that it kind of like attaches to various places, right? When you drag it around, don't let go. You drag it around, right? It'll highlight. So when you start dragging your pill, right, what do you notice? Fellas, what do you notice? Orange, okay? So things do turn orange. Yeah, so they turn orange because they tell you, okay, you can drop it here, you can drop it here, you can drop it here, and every other spot, okay? So it's just to say that these are the places you can drop. So what we're gonna do first, right? We're gonna try creating a bar chart. So everyone, I would like all of you to rename this to bar chart over here. Just call it bar chart. That's it. Just call it bar chart. And guess what we're gonna do here? We're gonna create a bar chart, okay, of our type of cost data. So we'll create a horizontal bar chart, okay? And how it works is that let's drag the number of graduates to our column first. Okay, maybe not. Yeah, okay, fine. We can do that. Now you click on this, right? Yeah, wait, let me just clear this. My bad. Remove. I'll drop it here, right? So right now it doesn't do much because it doesn't mean anything, right? Over here. Right now this thing is, what is this? This is a attribute. So we need to change this into, we need to turn this into an attribute. Oh wait, no, not an attribute, sorry. Into measure. Into a sum, right? So, oh wait, let me just repeat. I'm so sorry, guys. Now, what I'm gonna do, right, is that I'm going to do two things. I'm going to create, how do I put it? I'm going to create the number of graduates for the type of course. So I'm gonna drag my, what's that? The pill, right, to one of the areas over here. So I'm gonna drag it right to the center. So everyone drag it right to the center. So now you notice that once I drag it to the center, I see the rows, it says number of graduates, right? Now, the next thing I'm gonna do, right, is to drag type of course into columns over here. So right now, what's happening is that it's still a bit weird. This is actually a table right now, and we do not want a table. Instead, what we want, right, is actually a horizontal bar chart. So what we can do is we can click show me on the upper right corner. So if you're ever confused or anything, right, you can click on show me, and over here, notice that it says for horizontal bar, you need 0 or more dimensions. So currently, right, these two, they're what? They're dimensions because they're blue in color. Oh wait, no, over here, right? 0 or more dimensions, and you need 1 or more measures over here, which is green in color. So we don't have anything that's green in color yet. So we need to change these guys to a kind of measure. So over here, right, notice that it says dimension, but you don't want that, you want measure. Good, there we go. Okay, so notice what happened here. So initially, right, we had 2 dimensions. Okay, I mean, you can flip it around, that works, whatever works. So you can just drag it around first. But for a bar chart to happen, notice that it says you need 1 measure, 1 or more measures, and 0 or more dimensions. So you need to turn one of them into a measure for a horizontal bar chart to happen. In this case, I want to measure the number of graduates. So I will go to measure, sum. There we go. Any questions so far? You guys give it a try. So 2 things I did. One is I dragged type of course and number of graduates. And the second thing I did was that at the pill over here at the side, there's an arrow that says down, right? It opens up and you can change from dimension to measure, where we're looking for sum over here. Okay, so let's give ourselves maybe 2 minutes to give it a try. Let me know in the chat if you're stuck. Give me a thumbs up if you're not. All good. Please let me know in the chat if you have successfully done this. Okay, good job. So from a data source like this, right? from this over here, what we successfully did was that we just dragged two things and, you know, a bar chart already appeared. Remember when I was trying to code something earlier today? You guys remember how I had to type code and then make sure that everything works well? On the other hand, for this one, I just drag and that's it. I'm all good, right? This is ridiculous. So easy. Who thinks it's easy? He's laughing. Okay, so now what if we want to arrange and kind of like reorder our bar, right? So what we can do is can I zoom? No, I can't zoom. I hope you guys can see this. So at the next of sum of number of graduates, there's this small thing over here that you can click. Okay, maybe I should change the size of my, oh, there we go. Okay, it's a lot easier to see. So over here at the bottom, there is a button that you can click to reorder your, cool, right? And then we can have alphabetical order also, right? Or just numerical. So, okay. For those of you who are curious and exploratory, right, what you all can do is just like click around and try different numbers, right? Different measures. So for example, I can get average. So you notice that the number changes, but the pattern is still the same. You can go with median, right? Median number of graduates each year. Can go with, I don't know what else. Minimum. Okay, so all these things, they work. Okay, I'm just gonna go with some. All right. Now, what else can we do? What else can we do with this? This is okay. All this, right, is the sum of, this is the sum for the number of graduates for all the courses throughout the years. Correct, everyone? Right. Okay. But what if we want to look at it? We want to look at it over the years. What can we do? We have to create a year filter, right? So what I like all of you to do with me, right? Correct. Is right now make sure you have everything like this, right? And what I like all of you to do is drag year into filter. So once again, drag year into filter, and something's gonna pop up, okay? And it's gonna ask you, how do you want to filter on year, right? How do you want to filter this particular data set based on year? So what you can do is just click on year. That's it. Click on years. Click next. And you can filter the data that you want, right? So what you can do is then use all and then press OK. So what I'm going to do is I'm going to delete this. I'm going to show you again, okay? Drag year into filter. The filter field will appear and it will ask you, okay, how do you want to filter your dates based on? Because currently we only have years, so that's why we can only click on years. Next, we will use all of the years present, right? So because if you select from this, right, you only be selecting a very specific number of years. So let's not do that. Let's use everything. So we click OK, right? There you have it. You have your year over here. Let me know once you guys are done and you have the year filter. Okay, all good, folks. Have you created your year filter? Okay, done. Thank you, Hayati. Okay. For those of you who are done, right, click on the bottom, click on the arrow over here, and you have a lot of options. Click Show Filter. So once again, click on the arrow, click on Show Filter. So what do you see now? What do you see? You see a filter, right, over the years. So what can I do? You can actually filter. You can see how the numbers change over time. So you can now filter your data set based on the year, right? So for example, if I wanted to see maybe 2000, year 2000, wow, okay, right? There wasn't anything in applied arts, it seems, and can have two of the years, but I don't know why you do that. But yeah, you now have the freedom to filter your data set according to the different years, right? Of course, some doesn't quite make sense. Instead, you should maybe go with average, right? So 1994, right? You can see how the average changes over time. Right, so this is pretty neat. And you can see that the engineering sciences has increased in average over time simply because more and more people joined joined the university. Okay, great. So we are more or less done with the bar chart. Of course, we'll be exploring other kinds of charts with the same data set. So let's hang in there, right? So, okay, cool. Let me just close this. Now, let's leave this alone. So next to the bar chart, you see, we are now going to work on a line chart. So line chart, let's click on the tab next to bar chart. You click on it and you will see sheet 2, okay? You have a second sheet. Now, second sheet, you double click your sheet, you rename it to line chart. Okay, rename it to line chart. As its name suggests, we are going to create a line chart. Let's see. Okay, great. So for a line chart, right, what's the first thing? Let's say if you want to build a line chart, but you don't know how to, what's the first thing that you should be doing? Look at Show Me, right? Correct. Because when you look at Show Me, you're going to get a clue on how you can build because the data set is selected already. It's still using the same data source. But it's just that you open a new sheet, right? You open a new sheet to make new kind of like report-ish. So when we look at the type of line charts, right, it says you need one date and you need one or more measures. So this is what we're going to do. So you kind of have an idea of which pill you're going to use. So for the date pill, which one are you going to use? Yeah, right. Okay, thank you. Awesome. So yeah, you know what? We're just going to put it randomly somewhere first. It can be here or it can be here. Okay. So the year column. Next thing, what we're going to do is use the number of graduates over here. Okay. Right now, does it work? It doesn't work, right? Because right now, this is still a dimension. So we need to change it to a measure. There we go. So change it to a proper measure. So measure to sum. Okay, so click on it, it becomes sum. Yep. Can what does this even mean? right? So if you actually flip it around, right, you're gonna get nonsense. So make sure the direction of the pills is correct. Of course, you can try. You can kind of like get the average. You can see that the average has remained constant. Sorry, for the first couple of years, and then it has kind of grown over the years. Some, right? So that's cool. Okay, that's awesome. Actually, this is quite a short segment. Just wanted to show you guys that you can plot this line chart just by dragging the year pill and the sum of the number of graduates over time. Okay, all good. Let me know if you still need a bit of time in this section before I move on to the next chart, next kind of chart. Okay, all good. Let's go. So let's create a new tab over here. Let's name it a pie chart. Okay, let's name it a pie chart. So what do we need in a pie chart? Let's head on to show me and take a look. Now, for a pie chart, right, you need one or more dimensions and you need one or two measures. Okay, so let's maybe create a pie chart, right, for the number of graduates, and then the pie chart just contains the different gender makeup, right? So the pie chart should have like what percentage is who and what. Okay, so let's do that. Let's go with number of graduates as the measure and sex as the dimension. So let's click on, let's do this, graduates and then sex. Now, number of graduates, what we'll do is that we'll just do a sum over here. Okay. Now notice that if you do a sum and sex over here, you get a bar plot. Is that what we want, guys? No, right? That's not what we want. So we click on this, right? We can actually change the kind of we can change the type of plots. By default, if you have a sum, if you have a measure, right, and a dimension at the same time, you get a bar plot. But if you just go ahead and click this, right, what do you get instead? So your pie chart, right? So initially it's small like this, correct? Do all of you have small charts like this? Small, right? So if it's too small for your liking, what I suggest you can do is go to standard over here. You see the word standard, you click on standard and you change it to entire view. Okay, once again, from standard, you click, it goes to entire view. Okay, all good, fellas? Okay, great. That's good. So now, right, so now you have your pie chart containing the number of males and the sum, right? And over here, we see something interesting. When you turned your bar chart into a pie chart, the pills were actually, the pills were kind of like rearranged. I hope you all notice it. So what you have here is the color. Color means, right, when you have a particular say dimension, it will separate itself into two or more, right, depending on the sex. And the angle over here, right, you notice that this is angle. You drag the measure in here, you get the sum of the graduates in each sex. And finally, the size, the size depends on the number of graduates in here. So what I'm gonna do, right, is that I will, because I want some labels up, this is kind of a boring pie chart, right? You only know the details when you hover over it. So what can you do? Do you notice there's something that can help us label our pie chart? You'll see it? Okay, I see labels, right? So let's start with labels. And let's label the sum of the number of graduates. So number of graduates, label, okay? Now, this is wrong, right? Because this is not the right thing. So what we're gonna do is that we're gonna turn this into a measure. There we go. Does this make sense, everyone? Perfect, awesome. Okay, of course you can try experimenting with other things, folks. Maybe I can put sex on label. There we go. If I drag sex and put it on label, the sex appears. Okay, so you can just experiment everything. So maybe you put a label here. Right, the moment you add a year, right, it becomes slightly complicated because it splits itself according to the year. So feel free to just play around with this. Don't worry, you really can't make mistakes. If you mess up, you can just kind of press the undo button, and that's it. It goes back to normal, right? So yeah, just give it a little try. Okay, tell you what, let me challenge you guys. I don't know if you're up for it, but I have faith in you. Now, so create a filter using type of cost. As mentioned just now, I requested for, say, doing a type of cost filter. Now, what you can do right over here, so previously what we did was that we dragged the pill into filters, right? And then after that, we just use all, right? We use all, you press OK. So nothing happens for now because we haven't done any filtering yet. So we'll show filter over here. We'll show filter. Notice that with the filter in place, you can now do things like this. So yeah, nice one. Okay. So that's how we create and use the filter. Okay, all good. So yeah, so that's how the filter works, I suppose. Oh, sorry, I keep burping. Goodness. Okay, next, what we're gonna do is we're gonna open a new sheet. Okay, folks, we're gonna open a new sheet. And we're gonna call it histogram. So we're gonna rename it. We rename it to histogram. Okay. Now, what I like all of you to do, right? Okay, I'm just gonna let you guys do something independently, and that is create a histogram using number of graduates. So you have maybe five minutes. Okay, 5 minutes too long. 3 minutes. Let's do it. Let's start now. Go. So first things first, look at show me, okay, and see what it says. So when you click on show me, right, over here it says for histogram view, try one measure, which also means you only actually just need one measure. So as mentioned, you need graduates. So let me just put graduates over here. I turn my number of graduates into a sum, right? And then I click on histogram. There we have it. You guys have this? Correct, right? Okay, well done. Well done to all of you. Now, what does this mean? Like, what does it mean to have this particular, like this particular histogram over here? Anyone? Yeah. So for those of you who succeeded in this, well done. So this over here, right? it kind of tells you like at some point how many students there were in the different majors, correct? So most of the graduates are found within this particular bin. What does it mean? It means, right, there are, I think, 248 rows that contain anywhere between 0 to over 100. Haha, okay. This one doesn't make sense. Okay, this one does not make sense. This one makes more sense, correct? So most of the courses, okay, how we can interpret this, right, is that actually most of the courses are small, right? Most of the courses are small. That's why you get most of the bins within here, the distribution. Okay, whereas you get a very small number of courses with large sizes of students. That's why a large number of graduates. So that's why you have the long tail over here. So this is one way to think about your histogram. Now, that's it. Okay, so wow, guys, you guys are great, right? So far so good, and you all managed to successfully do it based on just show me and a few other clues. So well done. Now, okay, we're actually done with this histogram, right? So it's kind of easy to do a histogram, right? Drag number of graduates, change it to sum, click on this, and then boom, that's it. So compared to the histogram that I prepared using Python earlier, and compared to what you see over here, which one is easier? Which one do you prefer? Yes, no, no, yes, no. No one? Okay, no mind. So, I mean, I'm just Tableau is easier, right? Correct, which is great. So next one we're gonna do is one last one for this data set. It's called a bubble chart, right? We're gonna do what you call a bubble chart. What's a bubble chart? A bubble chart is a chart that contains multiple circles to indicate the size, but we'll see what it is later on, okay? It sounds a bit abstract over here, but yeah. Okay, so right. So over here, let's double click this and change it to bubble. Okay. So bar chart, line chart, pie chart, histogram, bubble. We will need to use, okay, so when we click on show me, right, let's see if there's any bubble chart. So bubble, for pack bubbles, right, try one or more dimensions and one or two measures, okay? Now, what we want is the number of graduates as a measure, right? So we'll have number of graduates as measure, type of course as dimension. Number of graduates, that dimension, let's just pick it over here. And then after that, type of course as, right, both of them are currently dimensions. But okay, let's take a quick look. Now we want number of graduates as our measures. What do? We go over here, we click measure, sum. Oh, there we go. Notice that immediately the moment I click sum, right, you open up a few other possibilities. And more specifically, the pack bubbles. So click on the pack bubbles over here, right? Give it a try. Click on it. What do you see? Wow. Yeah. Also, this right now is a standard, so can just go with entire view. There we go. I'm just gonna let it sit here for a while. Give me a just give me a yes when you have it. Okay, awesome. So this is what you call a bubble chart, right? So yeah, that's it. So look at that, the pills are now moved from here to here because you changed the type of chart, right? Yeah, so feel free to just kind of like experiment with things. So for example, what I'm gonna do is that I'm gonna drag let's see, number of graduates to Wow, that's pretty nuts. Maybe not. Oh yeah, one thing that's useful. Tooltip over here. Okay. So you notice something when you hover? Hover. So let me just undo, right? When I hover over, what do you see? You see type of course, and you see sum of number of graduates, correct? Now let's say if I say drag something down to tooltip, it doesn't quite do anything yet. So what I'm gonna do is just oh wait, okay, maybe not. Oops. Error. Okay, forget it. So I'm just gonna remove it. Sorry. The tooltip over here, right, will tell you what kind of information to put when you hover over the bubbles. Okay. Now, what else, we're gonna measure to the size pure. So number of graduates to the size. Wow. Okay. Maybe not. So you can just try experimenting all the different kinds of combinations. Personally, I actually I have no idea sometimes like what will happen if you drag certain things to stuff. Wow, look at that. What happened here? So the moment I dragged say sex to detail, right, we split off into two groups of bubbles, one for males, one for females. Yep. So I guess that's some of the things you can experiment with. But yeah, this is a bubble chart. Now, question: what is a bubble chart used for? Don't overthink it. Just tell me what's a bubble chart used for. For categorizing, okay. Don't know, never used it. Okay. Well, if you never used it, try to guess what it's used for. Size comparison, okay. Size of circle, yep. Okay. So I think all of you are onto something. So when you talk about size, right? Now, humans are very visual creatures. Can we all agree on that? Humans are very visual creatures. Yes. We like to see. We see, we judge, right? So when you create a bubble chart like this, right? It kind of makes it easy for people. Yeah, exactly. Just see 1 point first. Thanks. Right. So yeah, so don't forget when it comes to data visualization, right? When you tell a story, we are always talking about the visuals, right? We're always talking about the visuals. You prepare a bubble chart like this, right? It's very easy to see like, okay, if I ask you, give me in 1 second, right? Tell me what is the biggest cost engineering science, right? The reason for that is because you look at it, you're like, okay, yeah, engineering science is pretty big. And then the next biggest is humanities and social sciences. Okay, the only tricky part, right? The only tricky part is when the circles are similar. So let me ask you this, everyone. Between business and administration and natural, physical, mathematical sciences, which is bigger? Okay, the same. Can you immediately identify which area is bigger, which number of courses has more number of graduates? Okay, let's take a quick look, all right? 28,313, 28,122. Okay, is this a trick question? Almost, but I just have to caution you when using dramatic visualizations like a bubble chart, you might want to take note of this somewhere. Just take note that you may have quantities which are similar to each other. And that will make it kind of hard to gauge or judge things, okay? In this case, I think no problem. Okay, here's another question. Between education and architecture and building, which one is bigger? Don't hover over it, tell me, visually speaking. So the question is, between architecture and building, right, and education, which of the two is, which of these two circles is bigger? Okay, architecture, don't cheat, Okay, so let's hover over it. 7377 6421. So for those of you who say architecture is bigger, well done, right? Now, again, it really depends on the data story that you're trying to tell. If my intent to tell this story is, hey, I want to say that engineering sciences is the biggest, can I use this chart? Yes, of course, because it's dramatic, right? Now, if I wanted to talk about something that's a bit more less straightforward, like business and natural sciences, should I use this? No. Okay, there are other ways where you can visualize the data instead. So I guess visualization, right, is almost an art, because you need, it's not only visualizing, it's not only kind of like, you know, drawing and whatnot, right? But also it's a matter of psychology and yeah, really thinking about what kind of story you really want to tell. Okay. Okay, so there we have it. We are done with this series of we're done with this series of analysis. Okay. Okay, thank you everyone for the Tableau session. This is great. Please do give it a try, because when you download this, right, you only have, I think, 2 weeks free license before it switches to the free version, right? The free version is also okay, right? So no worries about that. So let's close this. Let's close this, and we are now going to go to the other one, which is hands-on data analytics on colab.research.google.com. Okay, let's do that. So everyone, make sure all of you have your Google account. So let's spend 5 minutes just setting up. So when you click on the link, right, this is what you see. Please let me know if this is what you see. Now, I would like all of you to click new notebook over here. Just click on new notebook with me. Okay, now that you've clicked new notebook, right, I need you guys to just wait for a bit. I need to prepare something important for all of you. Give me a second, real fast. So this part is slightly more challenging, and I would need to kind of like brief you guys on what to expect. Okay, folks, something that I need to tell you about. So this is how you will arrange your notebook. So what I'm gonna do is that I'm going to zoom it to 125% so that you can see. And what I need all of you to do, right, is to, right now you're looking at my screen, correct? What I need you to do is to cut the screen into half. If you are using 2 screens, no problem, no worries. But if you are using only 1 screen, right, and you've been following my stuff on Tableau, I will need all of you to kind of like do something like this. I will zoom my screen so that you can see everything, right, large enough. But I will need all of you to kind of like divide it into 2 so that you can code along with me. Okay, ready? So make sure that your screen is something like this. Half of it belongs to your notebook. Half of it belongs to the Zoom screen right now. So we'll go with we'll just name this code along. Okay, so what is Colab? Colab is a platform by Google, right? And it's designed for you to run code online, right? Meaning you do not have to install anything. You do not need to set up any coding environment. The only thing you need to do is to go to the URL and start coding. How amazing is that? Okay. Google Colab is very powerful. It contains hardware strong enough for you to do AI, machine learning, and deep learning tasks. But for today, we are just going to do a bit of data analytics work. So before we do anything, right, you see this connect over here. So click on connect so that you can connect to Google's servers. Okay, great. So let's do a bit of fundamental coding for maybe just a quick while, right, before we jump into performing data analytics. I am going to assume that all of you have not done Python before, and I will do my best to kind of like, do this crash course with all of you, all right? So without further ado, let's begin. So type with me print. Notice that when I type the word print, right, and then I press open bracket, you notice something? The color changes, okay? So this means that the print over here is a special keyword. And I'm going to print my name. So what I'd like you all to do, right, is to print something that's within the quotation marks. So make sure you have the quotation marks over here. If you do not have a quotation mark, what do you see? You see a red angry underline, right? And that's no good. Okay, so there's this underline thing, right? So once you fix it, that's it. So this is Colab's way of telling you that you might have some kind of error. So what happens if you make an error? You will get an error message, right? So this is what we call an error message. Everything is underlined. So, okay, print. So this is one of the many functions that we have. Now I'm gonna add comments, right? So comments, right? When you comment, this is a comment. Nothing gets run because this is just a comment. So if I were to print, say comment, would I see something over here? The answer is yes, right? Because I use the function over here, whereas this is just a comment to comment my code. So, hello everyone, exclamation mark. Okay. Now, apart from printing, you can also just put this, hello everyone, and you will see that there's hello everyone. Now, notice, is there a difference between the hello everyone here and the hello everyone here? The difference is actually, yeah, one thing is syntax, right? But another thing is that you notice there's actually the the single quotation mark here, right? So over here is a print, output from a print, and this one is just the notebook kind of like showing stuff, right? So over here is just an output from the notebook. This is output from the function. So maybe what I can do is output from notebook. So this comment is output from function, right? The print function. So what print does is that it does some kind of thing, right? Which is a function. It does a specific function. Now, anyways, so this is it. So what I'm gonna do is I'm gonna scroll down and I'm gonna write more code. By the way, does anyone have any errors yet? Has anyone experienced any errors? Okay, that's good. So far, so good, right? If you experience any errors, right, folks, don't panic, right? Try to troubleshoot it. So if you experience any errors, just try to compare your code with mine. Make sure that whatever that you type out is the same as mine. Okay. So, like for example, let's say if I do this again, right? Then you notice this arrow over here. This arrow will tell you where your error is. Okay, so just use that, and if you still can't fix it, right, just post that error in the chat, and I'll help you troubleshoot. Okay, so basic things, you can do basic things, right? Like 1+1. You can do all kinds of operations, multiply. Right. Wow. So fast, so good. Right. Now, question: what are computers used for? Why are computers called computers? Right, to compute, right? So they compute things very fast, right? And we are the ones supplying the instructions, but ultimately they're the ones who do the computation. So your computers can do all kinds of different kinds of computation. So first of all, it's multiplication. Right, so you have all kinds of things, right? Like addition, subtraction. I'm just going to show you multiplication, division. So, okay. So this is a division, right? What else? So I'm gonna show you something. And you guys tell me what this function, what this operation does, okay? Okay, pay attention. So first of all, 6 mod 5, you get 1. 6 mod 2, you get 0. 10 mod 3, you get 1. What do you think mod does? Find remainder, correct. Exactly. Okay, so you can give it a try, right? So 10 mod 3, I don't know, 10 mod 8, what do you get? You get 2, right? So that's what it does. In our context, it's not that useful because we are not looking for remainders or anything. But in certain operations, it's very important to find remainders. So we'll skip that. So first of all, what we've learned is that we've learned to print something. We've understood that the output from the notebook is different from output from a print function. We can perform all kinds of mathematical operations on it. And we've learned, I guess, the syntax, the kind of like the grammar for multiplication, division, and modulus. Okay, so we're moving blazing fast. Okay, let's see what else. Let me skip. We're gonna skip many things. We're gonna skip quite a few things, but I think from here on it's just the basics. So the basics really is quite a lot of things basically, but I am covering the bare minimum so that we can do a bit of analysis work. But before we go, right, does anyone remember this thing? This word? Anyone remembers this word and what does it do? What's the purpose of such a thing? Yeah, to import library, not data, to import pre-written code. Okay, so the pre-written code, right, is useful because you don't have to write all kinds of things, right? Because okay, let's import this library called random as RD. So what it does is that the original name of the library is called random, right? But I'm just gonna call it RD just for short form, okay? So that I have a reference to what RD does. Now, okay, you know what? Actually, let me take that back. Sorry. Okay, one more important thing I should teach you guys before I move on to intermediate things. Here's a question. When you were in school, right, when you were in school, your teacher said x is 3. What is x plus x? What would you say? Bear with me, this is a silly question, but this is important. Six, right? Why 6? Because x took on the value of 3. Okay, x took on the value of 3, which means x contains the value of 3. X equals to 3. And when I put x, right, what is the output? Ta-da, correct. So what I'm gonna do is x plus x. What do you think we'll see? That's right. There we go. Okay. So what have we done here? We have assigned, okay, the full vocabulary for this is that we assign the value of 3 to x. Okay. We assign the value of 3 to x. We assign the value of Jackie to y. So when I do y, when I run this line of code, right, what's going to happen? What do I see? Who said graph? Okay, it's actually Jackie, right? Correct. Because what did we do? So once again, I think to reiterate, we assign the value Jackie to y. Okay, to variable y. So y is a variable, x is a variable, correct? So that's kind of like the terminology that I'd like all of you to get acquainted with. Okay. So let's go. Let's continue. Import random as rd. So what does random do? Random, right, is a library that generates random numbers. Okay. So random.rand. Okay, I'll just type with me. Okay, what we're gonna do is generate a random integer. Now, what is an integer? Integer is a whole number. Okay. So integer is a whole number. Okay. So in that case, right, so what we do is rd.rand int. Oh, okay, maybe not rand int, sorry. Let me see. Random. Okay, random. Wow, okay. So what random.random does, right, is that actually random rd.random generates a random number between 0 to 1. Okay, so how do I know this? I mean, there's this thing called documentation. When you Google, right? When you Google kind of like the random library, it will give you a list of things to look at. So basically, what each function does and what not. Okay, so but don't worry about it. The idea is that when I do rd.random, right? So this over here is library, correct? Library name dot function inside the library. Okay, so notice that, okay, let me just add some space to make it look more legible. Okay, does this look familiar? Does this particular structure look familiar? Do y'all remember from this morning? What do y'all saw? Anyone? Yeah, I hope some of you would have gone to see the what's that, yesterday's, no, not yesterday, what am I saying, this morning's notes. Remember pd.read CSV? Does this look familiar, folks? How about stats.man-whitney u? Fellas, oh no, have you all forgotten everything from this morning? My heart hurts. No, just kidding. Sorry. So the structure is the same, right? So library name dot function inside the library, and then it does whatever it does. Stats.man-whitney u. So in this case, we are taking in two different values, right? So generally the structure is like that. So rd dot say randint. So what I'm going to do is I'm going to generate a random number between 1 to 100. So this is what randint does: generate a random integer between 1 to 100. Notice it's all random. Now, suppose I want to save my random number. What can I do? Yeah, we assign it to a particular variable, right? So, for example, what I can do is over here, I can put z equals to random.randint 100, right? And we can use z anytime we want. So right, so don't overthink it. I didn't mean to ask such a tricky question. It's not a tricky question, folks, right? So if you want to save a particular piece of information that comes out of a function, right? For example, this one, you just assign it to a variable, correct? So this is also why, right, earlier on today, this morning, what I did was df equals to pd.read CSV, something, something, something. Then I subsequently just kept using df. Does this ring a bell? Does this look familiar to all of you? Do you remember this? I used the word df. Okay, I hope this kind of like rings a bell, right? But don't worry, we'll go through it again. Okay, so yep, data frame. That's right. Okay, so this kind of covers it. I think let's proceed. Now, this morning, what we did was that we imported pandas as PD, right? We also imported matplotlib.pyplot as PLT. We also import cbon as SNS. So we give all of these long library names, right, with something shorter, right, so that we can use it more quickly. Yep. So there we have it. We have PD, PLT, and SNS. So each of these libraries, right, they do different things. So do you all remember what matplotlib is used for? Graphing, right? Graphing / visualization. SNS, what is it? Visualization, that's right. So same thing for graphing / visualization. Okay. Now, let me go retrieve the data set for you guys. Give me a second. Okay, we're using both, right? Because one library can do one thing better. Okay, usually these two libraries are used together because one library can support the other library with certain things. Now let's look at a particular data set that I want to introduce to you guys. It's called the diabetes data set. So over there, right, you see the link that I've shared with you. What I want you to do is type with me df equals to pd.read CSV and the URL that you see over there. Okay, the URL that you see over there, run this cell, you should see something like this. Run this cell, and you see something like this. Don't forget, press Shift Enter. So, do you guys want a bit of historical context? This is a very commonly used data set for learners. So the data set is actually called the Pima Indian diabetes data set. And historically, I guess to give you a bit of context, right? The data was collected on a bunch of different people, and the idea was that, hey, can we actually predict can we predict diabetes status based on their various kind of like things over here. So this is a relatively simple data set. 1 means diabetic, 0 means not diabetic. Okay, so 1 means diabetic, 0 means not diabetic. Any questions so far? So typically, right, in a data analytics project, the first thing to do, right, is to actually understand each column over here. Or we'll be doing a few things. So I'm just gonna start with this. Okay, check if there is missing data. So what happens over here is that we need to check for missing data. And the reason why we check for missing data is sometimes because if you don't check for missing data, you will end up with errors or whatever. So in Tableau, right, it's very easy to work with data because, like, let's say if you have like wrong data or poor, like low quality data, there are actually ways for you to clean it. For Python, right, let's say if you work with the data but you accidentally don't clean it, or if they're missing data somewhere, right, you will encounter some kind of error, right? So let's go ahead and do this. So type with me, everyone. df dot is now dot sum. Okay, press it. Okay, before we understand what this is, right, let's just remove dot sum first, and we'll do is now. So what this function is doing is asking whether the data at a particular spot is missing. And if it says false, what does it mean? Not missing, correct? So false means not missing, not missing, not missing, so on and so forth. And when you sum it, so you're summing up all the false, right? So if it's false, it's 0. If it's true, it's 1. So the fact that the total for each of these columns is 0 means there's nothing missing, right? So this is, I guess, just a quick way to check whether there's anything missing in the columns. So our data set seems complete, which is great. So we can then proceed with the analysis. Now, let's start with understanding this column over here. So what's the best way to kind of like understand the distribution of pregnancies within this column? Not missing, no, how do we know? This is the number of pregnancies the people have. The number's kind of wild, but I think let's just roll with it. So what's the best way to examine the distribution or understand the kind of like what's happening in the column data? Histogram, okay, let's start with histogram. So let's do that. Okay, I hope all of you remember how to do a histogram. plt.hist. Now the way to get the way to get the data, right, from your table over here, the data frame, is that you start off with a square bracket followed by the name of the column. So there you have it. You actually extracted the single column. And so what you can do is just plt.hist pregnancies, and there you have it. Okay. Now, what does it say about the distribution of pregnancies in the data set? Okay, good, great. So I think, okay, so as the role of a data analyst, right, your role is to more or less just try to understand the data set as much as you can. And also kind of like make observations about what's going on over here. So for example, right, in this particular case, what are your observations about the data set? The thing is, how can, I think, this is kind of wow, isn't it? Like, how can, yeah, like you can, but it's just kind of wow, right? How can you have, do you know anyone with like 17 pregnancies? It's pretty crazy, right? But anyways, this is just observations. Then next, you have glucose, right? Now blood glucose, you can check out the distribution as well. So you can replace pregnancies with the glucose. Okay, does this look normally distributed? Sort of, right? Because there's a bell curve. Okay, so what I like all of you to do is just kind of give it a try. So just give maybe one or two other columns that you like to try, okay? And then we circle back. So take maybe just 5 minutes to explore the data set, and then we come back and discuss. Okay, we have, okay, I hope all of you just spent some time just messing around with the code, right? They all managed to try anything else apart from these guys over here, skin thickness, insulin, BMI, so on and so forth. Anyone? When you are checking out the distribution of the values, right, did you all notice anything interesting, wrong, or weird? Which data is better? Which data is better analyzed using Colab, and which data is better analyzed using Tableau? Wow. Okay. Data that requires a lot of cleaning and reformatting will benefit from coding. Will benefit from reformatting. Whereas clean data, clear cut, like it's been cleaned and reformatted or whatever, right? It'll benefit more from Tableau because it's a lot easier, right? Cleaning meaning we haven't quite talked about this, but sometimes in data set, right, the entries can be quite dirty. Dirty in the sense that, let's say, what's an example of a dirty data set? Since you asked about this, I think it's a good chance for me to talk about, I guess, a dirty data set. So what is a dirty data set? Oh, bad idea. Okay, whatever. Okay, so age, let's say by age, gender, location, okay? Guys, this is a nightmare. Do you think this is a nightmare? If I want to analyze this, right, do you think So this is an example of very dirty data, right? Correct, guys? I mean, this is the worst example already. However, right, so the act of cleaning it, what's the act of cleaning it? The act of cleaning it will be like, oh, you gotta change it to 12, make sure that it's actually not 987, maybe we remove it because it's clearly someone messing around, right? And then over here you have male, right? And then you have big M, and then this is okay, and then you have big F, right? And then F, male, M. It's horrible. So what you need to do is just turn it to M, 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 F, F, M, M. Now, this is actually the worst. Location data is one of the worst things to analyze because of how complex it is. So, Singapore, Malaysia. Now, what's wrong with this? It's actually KL belongs to Malaysia, but there's nothing to say that it's Malaysia, correct? So, a proper cleaning strategy would take Kuala Lumpur and replace it with Malaysia. And then Brunei, change to Brunei. And then this is additional information that shouldn't be there, which is Orchard Singapore cannot, right? So Singapore, SG is actually Singapore. Singapore. So this is what people call cleaning. This is what professionals call cleaning. So, yep. Is that better? Does this answer your question? So this is a lot easier to do using Python than Tableau. Of course, right now I changed it to Excel, right? But if you were to fix this, yeah, you shouldn't be doing it in Excel in the first place, right? If you use Python, you can edit and fix them automatically and quickly. Okay. Yeah, even Excel takes forever, right? But it's very fast using Python. So okay. Well, we were back over here, right? Now, question. Again, the question was: do you all notice anything weird or interesting when you were doing your data exploration? It's not a riddle. It's not a riddle. If you've kind of like done the analysis for like most of them, right? You notice that insulin. Okay, let's talk about insulin. Actually, I was just trying to ask you guys if you all notice anything weird. Actually, you don't even need this, right? Because when you look at the numbers over here, what do you notice? How come? Why are insulin levels at 0? Why are insulin levels at 0? That's not good. Right? Makes sense, right? Because insulin, biologically, it doesn't make sense to have insulin at 0, because if you have 0 insulin, what happened? Okay, oh, not good. Okay, another thing that's kind of odd, right, is actually something that you want to take note of is the fact that there's someone with 16 pregnancies. Fellas, do you know anyone who has 16 pregnancies? Yeah, there's a 0 BMI, right? I think, let me just do a quick BMI. So that's why it's important to kind of like do all this there's a minority over here with 0 BMI. That's not very. Yeah, that's wow. Okay, so I think when you look at all this, you can start thinking about, oh, what's wrong with this data set? Holy, wow. Okay. Yeah, age. Okay, I think age should be fine. Yeah. Okay, it looks fine because you have people from plus 20 all the way to down. This is actually the most normal one already. But when you talk about BMI, right? Why do people have BMI? Over here, there's 0. Not good. Yes, this is dirty data. And how do we clean this? It's beyond this. Well, we can. Okay, Sarina proposes that we remove those data sets. Possibly we could, but yeah, there's no but. I think we can. But I think for this particular case, right, my goal is to let all of you kind of like think about this data a bit more, right, before going to it. So age is fine. Outcome, okay, outcome, right? Outcome. So what we're gonna do is that we're gonna do SNS. So type with me, SNS.count plot bracket df outcome. Okay, there we have it. Okay, not too bad, not too bad. So we have like 500 people without diabetes and close to 300 with diabetes. I'm looking at the okay, I'm looking at the questions. So how do we clean this? Actually, you need to spend a lot of time just understanding the data, right, before making an effort to clean it. So that's where all your exploration comes in. That's where all the understanding comes in. The anomalies, if you're aggressive, right, you can just remove rows with anomalies. But if you work with data, I think there's this feeling that you should preserve as much data as you can, right? Yeah. So, anyways, that's that. So, based on this, right, shall we think about what stories we can tell? Doesn't have to be outcome. It can be anything between pregnancies and other bodily functions or whatever. So be creative, come up with it. Possibly it could be gestational diabetes, right? Right. So one way to look at this, let's say, so Sue, right, talked about how people during pregnancy have body weight. So maybe one thing that we can investigate is there a relationship between, say, pregnancies and BMIs? What do you think? Weight of baby is different. Well, let's see. All right, let's give it a go. So I guess we can start with just a simple investigation of the relationship, right, between the number of pregnancies and BMI, right? We just want to see the correlation. Shall we do it? So what kind of plotting should we use? Okay, I see all of these interesting stories we can look at. So for, let's say, pregnancies and BMI, right, we probably should use a scatter plot. Okay, so let's do a scatter plot, folks. So press shift and, okay, so I'm just gonna add code over here. So code with me, plt dot scatter, right? So df, what's the x-axis? Maybe our hypothesis is that the more someone gets pregnant, the higher, the larger the BMI. Okay, quite reasonable. So let's go with pregnancies. Press shift enter. No, okay. All right, what's going on? Wait, this is BMI, right? Yeah. Do y'all see anything weird or interesting? Anything? Is there any story you can tell? 0.0 is really high. So it seems like, pregnancy is kind of independent of BMI, and I don't think there's any relationship that we can really draw. So that's okay, right? That's okay. Let's take a look at the DF again. All right, let's take a look at DF again. What other things shall we investigate? Anyone? Okay, age, pregnancies, and blood pressure. All right, let's go with pregnancies and blood pressure. Blood pressure, this should be interesting. So PLT dot scatter. So PLT dot scatter DF, pregnancies, DF, blood pressure. Okay, not really. Doesn't look like there's a lot of correlation, it seems. Also, another thing over here is that you realize the blood pressure, right? The blood pressure, we have a lot of zeros over here. We can't do tree data, not for this case, not in this case. Age and blood pressure, sure. Oh, now we're talking. Okay, so okay, now we're not talking. Actually, there's not a lot of relationship, is there? Sorry, I hope all of you can't hear a meow. It's actually my cat. I feed my cat at 6 o'clock, but he starts meowing at 4 o'clock. Sucks. Okay, so age and blood pressure doesn't seem to be anything. Pregnancies and BMI not so much as well. You really love cats. Okay, so what else? Skin thickness. Probably you can start like doing scatter plots between these different things. So one thing maybe we can look at, right, is using a what's this, a box plot for outcome and one of the various things over here. So when you do box plot, right, for this you may see interesting things. So let's go for it. Let's go for it. So everyone type with me. So early on, someone asked me, right, like why are we doing PLT and SNS? Like why am I importing the two of them together? The reason for that is because it's easier to do a box plot using SNS rather than PLT. So for example, okay, let's go. Data equals to DF, X equals to outcome, Y equals to, let's go with age for now. All right, guys. Haha, nice. Okay, sure, let's do this. What do you think? What do you think this says about the distribution of the age of people with diabetes? Yeah, 2040s, right? So for those who do not have diabetes, right, they tend to be younger, right, as opposed to say those with diabetes are a bit older, right, over here, right? Of course, so age seems to be a factor. How about BMI, folks? Wow, okay, so it seems like, let's say, the median, right? The median for people without diabetes, it seems to be around 30, whereas those with diabetes is slightly higher. So again, in such a case, right, okay, this is almost like revision for this morning. So the question is, it seems like there's a difference between the BMIs of people with and without diabetes. But for us to be very sure, what should we be doing? Right? We should run a statistical test. So basically, this is what an analyst does, right? Really just plot and then conduct statistical tests and whatnot. But I think according to my experience, there should be a significant difference. Okay, so last one. So maybe let's take a look at pregnancies. Aha, okay. Interesting. So maybe those who get pregnant very often may have a higher risk of getting of getting diabetes because of gestational risk and whatnot. So yep. Okay. Any questions so far? Yeah. So we've come to the end. I think it's a little bit slightly early. I apologize for that, but I guess that's what happens when all of you are such good students, right? And I thank you, all of you, for your kind attention. Right, I thank all of you for your kind attention. So, okay, thank you for being with us here for this session. I think before this thing ends, I think Recap or Honey probably has something that they probably want to say. Okay, I leave the floor to you, please.
Thank you so much, Jackie, for leading us through the ways of using data analytics and also your patience while you guide us. Even I had a little bit of fun just now using both Tableau and Code along. Also, thank you everyone for trying it out and maybe even challenging yourself. So as we come to the conclusion of this event, I would like to invite everyone to answer a poll that should pop up in your Zoom chat right now. And you may also scan the QR code on the screen or click the link sent in the chat to answer the questions. I will be sending it now. So you can go ahead and answer that. Your feedback is greatly appreciated for our upcoming workshops. So if you enjoyed today's workshop, there will be a similar one on drones and robotics on February the 25th. So you can keep an eye out for the registration link by following AITI or Recap on their social media. Thank you again to AITI for this opportunity to expand our knowledge on data analytics, and also Jackie and your celebrity cat for being so kind to share your insights on the industry. All right. With that, Assalamualaikum warahmatullahi wabarakatuh, and have a great day. Thank you so much for joining, everyone.